Welcome to the Unit 4 Section 1 video on arithmetic sequences. The first thing we want to do in talking about arithmetic sequences is how we identify them. During a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time that you see the lightning until the time you hear the thunder. So here is a breakdown of how long it takes to hear thunder based on how far away it is. So for example, if lightning is 0.2 miles away, it's going to take 1 second to hear the thunder. If the lightning is 1 mile away, it's going to take 5 seconds to hear the thunder. This graph shows the information from the table. If the points on the graph are connected, what kind of figure would you have? Well, you would have a line, and that would represent a linear equation. When you list the times and distances in order, each list forms a sequence. A sequence is the list of numbers that may form a pattern. Each number in a sequence is a term. In the distance sequence, each distance is 0.2 miles greater than the previous distance. When the terms of a sequence differ by the same non-zero number, in this case we're going to call it D, the sequence is an arithmetic sequence, and D is the common difference. The distances in the table form an arithmetic sequence with D equaling 0.2, because if you add 0.2 to each of the distances, you get the next one in the sequence. So an arithmetic sequence is a sequence in which each term after the first is found by adding a constant called the common difference to the previous term. The variable a is often used to represent terms in a sequence. The variable a sub 9 is the 9th term in a sequence. To designate any term or the nth term in a sequence, you write a sub n, where n can be any number. To find a term in an arithmetic sequence, add d to the previous term. So to find a term of any term of an arithmetic sequence, you're going to take the common difference, add it to the previous term to find the next, where a sub n minus 1 is the term before a sub n. So let's take a look at an example. Determine whether this sequence is an arithmetic sequence. If so, we're going to find the common difference in the next 3 terms. So to determine if it's arithmetic or not, we have to see if there is a common difference. So we're going to look at the difference between each two. So 12 to 8, we have to subtract 4. To get from 8 to 4, we have to subtract 4. To get from 4 to 0, we have to subtract 4. Since we have the same value being subtracted each time, we do have a common difference, which means the sequence could be arithmetic if the sequence continues in the same pattern. And the common difference would be negative 4. So the next 3 terms would be 0 plus negative 4, which gives us negative 4, negative 4 plus negative 4, which gives us negative 8, and negative 8 plus negative 4, which gives us negative 12. Each succeeding term, we just subtract 4 from the previous one. We're going to determine if this is an arithmetic sequence. So again, we have to check between every 2. So to get from 1 to 4, we have to add 3. To get from 4 to 9, we have to add 5. And we can stop right there because we already know it's not arithmetic because we did not have the same number being added to the previous term to get the next. And just for completeness, you have to add 7 to get from 9 to 16. So this sequence is not arithmetic because the first differences are not common. To find the nth term of an arithmetic sequence when n is a large number, you need an equation or rule. We want to look for a pattern to find a rule for the sequence. So we're going to have a position number, 1, 2, 3, 4. That's going to be our n value. That's going to give us a sub 1, a sub 2, a sub 3, a sub 4. In our sequence, we have the value of our terms, 3, 5, 7, and 9. Now, taking a quick look at this, you notice that it is arithmetic because our common difference is 2. You add 2 to each term, you get the next term. Well, we can find a rule to find some other term because you don't want to keep adding 2 every time if you want to say find a sub 500. What's the 500th term here? We don't want to keep adding 2 and do that 500 times just to find what the 500th term is, but we can create a rule to do this. So let's look at the pattern here. Our first term is 3, and in algebra we call it a sub 1. That's the designation it has. To find our second term, we're going to take our first term and add a common difference. So we have 3 plus 2 equals 5. Our term is our second term, so we have our second term is a sub 1 plus 1d. Our third term is our first term plus 2 common differences. So 3 plus 2 times 2, which is 4, equals 7. So we have a sub 1 plus 2d. Our fourth term is our first term plus 3 common differences. So you notice the number of common differences that we have to use to find our term number is 1 less than the term number itself. Okay? To find a sub 4, we're taking a sub 1 and adding 4 minus 1 common differences, or 3 common differences. So we can write this for any nth term. The first term plus n minus 1 common differences. So we have 3 plus n minus 1 times 2, which would give us the nth term of this sequence. And in algebra, generally, we'd say a sub 1 plus n minus 1 times d, our common difference. So if we take that our nth term is just what we found in terms of n, we can distribute the d first, distribute our common difference, and now let's swap our a sub 1 and dn terms. Let's take those first two terms and flip them, and then group our last two terms. Now we can redefine a sub 1 minus d, because to find the next term, you add a common difference. To find a previous term, you're going to subtract a common difference. So if we were to subtract d from a sub 1, we would get the 0th term, or a sub 0. So we're going to define a sub 1 minus d as a sub 0 and substitute that. Now we have an explicit formula for an arithmetic sequence. And you'll notice the similarities between this and the slope-intercept form of a linear equation, y equals mx plus b, where y is the value for the nth term, a sub n, m is the slope represented by the common difference, x is the term in the sequence n, and b is the y-intercept represented by the value of the 0th term, a sub 0. So let's take a look at some examples of how to use the explicit formula. We want to find the indicated term in each arithmetic sequence. So if we want to find the 22nd term of this sequence, we're first going to find our common difference, which is negative 3, because 5 minus 3 gives us 2, 2 minus 3 gives us negative 1, negative 1 minus 3 gives us negative 4. So we're going to use our explicit formula. We have a sub 1, which is 5, that's our first term. And we're going to subtract our common difference, negative 3, which gives us 5 plus 3, which is 8. So our 0th term is 8. Now we're going to take our explicit formula. We're going to plug in d, we're going to plug in a sub 0, and we're going to plug in 22 for n because we want to find our 22nd term. And to find the 22nd term, we just do negative 3 times 22 plus 8, which gives us negative 58. So the 22nd term is negative 58. And we did not have to subtract 3 22 times to get there. For b, let's find the 15th term. If a sub 1 is 7 and d equals 3. So here we have the common difference. We're already told what a sub 1 is explicitly here. So we're just going to plug in a sub 1 and d, and we're going to find that a sub 0 is 4. So we plug in d, n, and a sub 0. N, of course, being our 15th term, so 15. And then we do 3 times 15, which is 45, and add 4, which gives us 49. So our 15th term is 49. Let's put this into a real-world scenario. The odometer on a car reads 60,473 on day 1. Every day the car is driven 54 miles. If this pattern continues, what is the odometer reading on day 20? So, our common difference is 54 because each day we are driving 54 miles. So that's the common difference between each day. The odometer starts at 60,473, so that's our first term. But we want to find our 0th term. So we take that 60,473 and we subtract 54 to get our 0th term. Then we're going to take our explicit formula, plug in dn and a sub 0, n of course being 20 because we're looking for our 20th day. 54 times 20 gives us 1080, and then we add those two values together, and on the 20th day, if we drive 54 miles every day, we will hit an odometer reading of 61,499. And of course, a word problem requires a word answer, so you would just give us a short sentence indicating your answer. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.